Hello everyone. In today's video we'll see algorithm 2 for hydrothermal scheduling. So this is algorithm 2. So algorithm 2 is short-term hydrothermal scheduling using gamma lambda iterations. So the first algorithm was hydrothermal scheduling based on energy. So this is the second one. Now here there are few important terms to be noted. The first one is what is the short term and what are these gamma and lambda iterations. See, basically while scheduling hydrothermal power plants we have two types. One is short term scheduling and the second one is long term scheduling. Short term scheduling will be normally scheduling of both thermal and hydropower plant, that is nothing but finding the value of PGH and PGT, and here scheduling will be done on hour basis, that is hour by hour scheduling. Hour by hour scheduling, that is for each and every hour for the entire time period, and for each and every hour the scheduling will be done. So long term scheduling is nothing but this mainly depends on water availability, and the reservoir discharge, that is the water discharge from the reservoir. So this purely depends on the water availability. So long term scheduling purely depends on the water availability. Then thereby we can schedule PGH and PGT, and so since it is depending on this, so this is basically the time depends basically on the water availability. So the scheduling will be normally from a week to year. So scheduling will be normally for a week to a year. So these two are the very important thing to be remembered. So short term scheduling is hour by hour scheduling, and long term scheduling is nothing but for a week or for a year. And here short term scheduling depends on the constraints of both the system, that is hydro and thermal, whereas long term scheduling mainly depends on water availability, that is nothing but the constraint of the hydropower plant. So this is regarding the two terms. Now gamma and lambda iterations, when explaining the algorithm I will tell you what it is. Now in the previous algorithm, that is algorithm 1 based on energy, we have taken the mathematical equation which is nothing but to minimize the function, which is nothing but total cost of the thermal system, and the constraint was the energy, energy supplied by the thermal power plant. But here the scheduling will be, or the algorithm will be written based on two constraints. So this is slightly different than the previous one. So let us write. So the problem statement can be given as, so what is the objective function here? So it is minimize. What we have to minimize? The total cost. So total cost Ft can be written as summation k is equal to 1 Nt Hk f of Pgt k. This is same as the previous one. Why we are writing only for thermal power plant? Because the cost or the total cost mainly depend on, when I say total cost, that includes the maximum part of the total cost is a production cost. So the production cost of thermal power plant is high. So in order to minimize or to get the optimal scheduling, we have to decrease the cost of the thermal power system. So that is why we write to minimize. So this is the objective function. Now here we have to write two constraints. So what are the constraints? So let me write the constraints such that one constraint is based on the PGH hydropower plant constraint. So hydropower plant constraint is nothing but the water volume available. So we'll write constraint for that. So I can write Q total will be equal to summation K is equal to 1 to N Q naught K HK. So K is equal to 1 to N indicates that the constraint is for the entire time period, that is still N value. And what does this give? So this gives the total volume of the water available for discharge. So Q total, where Q total is the volume of water available for discharge. So this we have written one constraint for hydro plant. The second constraint what I am going to write here is for the power balance equation. So what is power balance equation? Whatever power is generated will be equal to power supplied. So this is a power balance equation. So let me write in terms of the nomenclature. So PD plus P loss will be equal to the generation. What are the generations? So it is PGH plus PGT. So let me write for the interval notation. So let me write it as for each interval, that is represented by K. So PD plus P loss. PD is P demand or P load plus P loss gives us the sum of some generation. So this is generation, this is the consumed power or the demand, okay, including loss. Now this same thing I can write it as PDK plus P loss K minus PGTK minus PGHK will be equal to 0. So these are the two constraints which we have to consider, and based on that we have to minimize the cost, total cost for the system. Now also we know that one thing to be remembered is summation K is equal to 1 to N, HK is nothing but the total time, that is the maximum time. This has to be remembered. So this is the basic statement for short-term hydrothermal scheduling using gamma lambda iteration. So let us continue. Let us write the algorithm. Before that we have to write similar way. What we have done in algorithm 1, we similar way we have to write a Lagrangian function. Then we have to write the scheduling. So we'll write a Lagrangian function. In the previous algorithm there was only one constraint, so we had written only one Lagrangian multiplier, but here we have two constraints. One is on total volume, water volume, and the second one is on power balance equation. This is called as power balance equation. Power balance equation. So we have to use two Lagrangian multiplier here. So let me write the Lagrangian function. So the Lagrangian function can be written as Lagrangian function will be equal to, the first part of the Lagrangian function is objective function. So what is objective function? This is objective function. So let us write that. So summation K is equal to 1 to NT f of PGTK HK plus lambda K. I am using one multiplier for the first constraint. I am using second multiplier for the second function. So it is summation k is equal to 1 to n, and let me write here. Yeah, let me use this multiplier for the power balance equation, the second one for water total volume water discharge. Why? Because the lambda we have in the previous case, we have used lambda for the constraint which included thermal power plant energy. So the same thing I am using for the power equation here. So this is PD, you can use interchangeably, but you should remember properly which is for which one. So PDK plus PD loss K minus PGH K minus PGT K, and lambda is for water volume. So this is Q naught K and HK minus Q total. So this is this equation I have written, or the constraint I have written, and for this one I have written from here. So this is this term minus Q total will be equal to 0. So let me write here itself. So it gives us summation k is equal to 1 to n Q naught k HK minus Q total is equal to 0. So we have written Lagrangian function based on two constraints. So this is a Lagrangian function. So this is a objective function for the mathematical model. So these two are the constraints. So lambda and gamma are the Lagrangian multiplier. Now in order to do the scheduling, that is in order to find PGH and PGT value, first we have to find out the coordination equation. Coordination equation is nothing but we differentiate the Lagrangian function with respect to the variables and then we equate it to 0. Now the variables here are PGT and PGH. So we will differentiate the entire equation with respect to both the variables, then we will equate it to 0. First let me differentiate it with the PGT. So differentiating, so this is what we get, differentiating with respect to PGT and equating it to 0. So when I differentiate this, since we have different variables here, we have to write partial differentiation. So partial differentiation of this with respect to PGT gives me, so differentiate this, so it is HK into differentiation of function of PGT with respect to PGT. Second term lambda K, differentiation of this, that is PD with respect to PGT is 0 because PD is not depending on PGT. P loss depends on PGT. So that is why we have written differentiation of P loss with respect to PGT. PGH doesn't depend on PGT, so 0, and PGT with respect to PGT gives me 1. So this is the equation and equating it to 0. Now by considering only this, we can simplify further. So what we have is, let me multiply this lambda K here, so we'll get this equation. And further we can shift this term to the other side. So lambda K will be equal to this term plus this term. So this is the first coordination equation. The second coordination equation can be got by differentiating Lagrangian function with respect to PGH. So similar way, so this is Lagrangian function. So differentiate this with respect to PGH. So first term, when I am differentiating with respect to PGH, it gives me 0 because there are no PGH terms. So this is 0 and we have to differentiate only these two. So I will be getting lambda K partial differentiation of P loss by PGH, that is with respect to PGH, minus 1, because from here this is 0, differentiation of this with respect to PGH is 0, differentiation of PGT with respect to PGH is 0. So only terms which are available for differentiation is these two. So partial differentiation of P loss with respect to PGH and PGH with respect to PGH is 1, plus the second term, that is the lambda HK, differentiation of this with respect to pGH. This is a water discharge, so this depends on pGH, so we have to differentiate it, minus the total volume of water in the reservoir will not depend on the generation. So that differentiation is 0. Only the discharge volume depends on pGH, not the total volume. Okay, so this is what we get. So simplifying further, so we'll get this equation. So lambda K and this term plus this term. So this is the second coordination equation. Now we'll write step by step algorithm for finding pGH and pGT based on this algorithm. But the thing is, before finding out pGH and pGT, we need to calculate these terms, that is the differentiation of this and also differentiation of this. And if you see in both the equations, this and this, there are terms which includes P loss. So if suppose we neglect losses, we can avoid these two terms, then we can write only these terms in the coordination equation. So we'll get, if I avoid or if we neglect losses, we'll be getting one coordination equation as this and the second one is this. Now in order to get pGH, so pGH is what and pGT is what. So for this purpose we need two terms. We have to first solve the coordination equations. These are the coordination equations. So in order to solve the coordination equations, we need these two terms. So first term what is needed is this, that is differentiation of function of pGT K with respect to pGT K. So now this is a cost function. F is nothing but cost function of the thermal power plant. So how to write the cost function? So f of pGT K can be given as A plus B pGT plus C pGT square. Let me use a T here for all these coefficients, because these are the coefficients of cost function which depends on thermal power plant. So let me write T here. So this is a cost function. Now if I do the differentiation, so differentiation of cost function with respect to pGT I have to do with respect to pGT. So this becomes a 0 plus this becomes a BT plus this becomes 2CT pGT. So let me write K here itself. So pGT K. So this is differentiation of function of pGT K with respect to pGT K gives us BT plus 2CT pGT K. So this one has to be remembered. And the second one what we have is calculation of, let me write here. So the calculation, second one what we need is calculation of Q naught K, which is depending on pGH. So we need this. Not here, Q naught is discharge, that is water discharge. Water discharge, and this depends, or this is a function of, water discharge is a function of pGH, and this can be characterized or written as mathematical model Q naught K is equal to AH plus BH pGH, or this can also be written as AH plus BH pGH plus CH pGH square. So these two are the equations which you can use as a mathematical model for the water discharge, and this can be used when or for generation below some limit, and this can be used for generation above some limit. So as per the requirement, this or this can be used. So if this equation is used, then differentiation of Q naught with respect to PGH can be written as, now differentiate this with respect to PGH. So first term becomes 0, so we have only BH. So this one, or if suppose you are using second equation, then the differentiation gives us BH plus 2CH PGH. So these are the terms to be used. Now a loss equation. Along with this, one more calculation what we need is, if suppose we neglect loss, only these two are the terms needed. But if suppose we require loss, then we have to calculate partial differentiation of loss with respect to PGT and partial differentiation of loss with respect to PGH. So let us write that. But loss equation, so the third one what we need is loss equation. So partial differentiation of this with respect to PGH and partial differentiation of this with respect to PGT. So how to write a loss equation? So we know we can write loss equation in terms of loss coefficients. So this is nothing but BTT PGT square plus 2BTH PGH PGT for kth interval, also BHH PGH K square. So this is the loss equation. We have seen this loss equation in thermal scheduling, where we had written it like this: B11 Pg1 square plus 2B12 Pg1 Pg2 plus B22 Pg2 square, like that we had written. But here the thermal and hydropower plants are the parts of the system, so we are writing BTT and BHH. BTT is loss coefficient for thermal power plant, BHH is for hydro, and this is for the combination. So this is, now we'll differentiate this with respect to the respective terms. So what we get from this is, so I have to differentiate this with respect to PGH. So partial derivative of P loss PGH. This term doesn't include any PGH term, so this is 0, but here I have to write 2BHH, that is for this, PGHK plus this is 2BTH PGTK. Similarly, partial derivative of P loss with respect to PGT. So from this it is 2 BTT PGTK plus, for this it is 2 BTH. We are differentiating with respect to PGT, so PGH term has to be written here, and for the last term it is 0. Okay. So these are the calculations needed before writing step by step algorithm based on short term gamma lambda scheduling. So step by step algorithm we'll see in the next video. Thank you.